Moving right along, number 12, I just want to identify the x and y intercepts. The x-intercept is where it crosses the x-axis, which it crosses right here at 1. And again, that's the same thing as the ordered pair 1, 0. The y-intercept is where it crosses the y-axis, which it looks like right here at 2. So the y-intercept is 2, and again, that's the ordered pair 0, 2. Okay, and thinking about that in terms of the zeros, that's how we have to approach number 13. Remember, the x-intercept is when y equals to 0. So if I plug a 0 in for y and solve for x, that'll give me the x-intercept. And the y-intercept is when x is equal to 0. So if I plug a 0 in for x, I can solve for y. And these will give me my two intercepts. So I've got 4x equals 12. I've got to divide each side by the 4. So I find out that x equals a 3. And then over here, I've got a negative 2y equals 12. Again, I have to divide each side, so I divide each side by the negative 2, and I find out that y equals a negative 6. So these are my two intercepts. The x-intercept is 3, the y-intercept is negative 6. But again, this is the ordered pair 3, 0. This is the ordered pair 0, negative 6. Okay? Taking a look at the next example. Here we want to write the equation of the line, and the two things we need to write the equation of the line are the slope and the y-intercept. Since this one tells us it's parallel to this line has a slope of negative 2, and parallel lines have the same slope, so our slope is also going to be negative 2. Now to find the y-intercept, I start with a fresh y equals mx plus b, and I plug in what I know. I know that the slope is negative 2, and then I have an x and a y value right here, this ordered pair. So I plug in the 3 for x, 3 for y. Now I just solve for b. So 3 equals a negative 6 plus b. To solve this for b, I have to add the 6 to each side. So I find out that b equals a 9. So now I have the slope, the y-intercept. Now I just plug it into slope-intercept form. So it's y equals a negative 2x plus 9. And that's it. Okay, find the slope, find the y-intercept, plug it in. Number 15 is very similar. We need to find the slope, we need to find the y-intercept, and we need to plug it in. Except this time it tells us that we're perpendicular to the line y equals negative 1/2 x plus 2. So this time, the slope of this line is a negative 1/2. But since we're perpendicular, we want the opposite reciprocal. So instead of negative, it's going to be positive. Instead of 1 over 2, it's 2 over 1. Okay, so I change the sign and flip it, which is really just a 2. So now I start with a fresh y equals mx plus b. And I plug in what I know. I know that the slope is 2. I know that I have an x and a y value listed right here, this ordered pair. So I plug the 2 in for x. I plug the negative 1 in for y. And I would just have to solve for b. So here I have to subtract the 4 from each side. So I find out that b equals a negative 5. So now my equation would be y equals 2x minus 5. Find the slope, find the y-intercept, plug it in. In number 16, I'm doing the same thing again. I need to find the slope and the y-intercept. Since I have two ordered pairs this time, to find the slope, I'm going to do my change in y over change in x. So here, y was a negative 2. Now it's a positive 5. Y has gone up by 7, so it's a positive 7. X was a negative 3. Now it's a 0. X has gone up 3, so that's a positive 3. And this one just stays as a fraction. It's 7/3. I still follow the same procedure as I did before. Y equals mx plus b. So I start with a fresh y equals mx plus b. Let me show that. And I plug in what I know, 7/3. And now an x and a y value, I can choose either one of these points. I'm going to choose the second one. And why would I choose the second one? Because that is the y-intercept. Look, 0 for x, 5 for y. I plug it in, b equals 5. And really, with this one, I don't even need to show this step that I showed over here because the y-intercept is given. It's a 5. So always look for those shortcuts. Y equals 7/3 x plus 5. All right? Either way, you should be able to come across the correct answer, regardless of whether or not you see that shortcut. Okay? For the next one, we're plotting my age versus the number of hairs on my head. So what we want to do here is we've got to scale this. I need to go from 18 to, I'm going to start here with 18. Let me extend the page a little bit. And maybe I'll go 3, 19, 20, 21, 22. Again, I want to use as much of the graph as I can. I could have spread that out a little bit more, but this should be all right. And now the hairs on my head, I'm going to put a little zigzag in here to say that the graph is condensed. I'm going to start somewhere around 70, and maybe we'll do 80. Well, I could spread that out a little bit more. There we go. And now I just have to plot each of these. 18,101 would be somewhere around here. 19,100 would be somewhere around here. 2091, so I'm just plotting each of these. 2182. And 2273. Be right around there. Okay? And now what I want to do is I want to construct a line that models this data well. And I don't want to use like the first 2 points here. The first 2 points wouldn't give me a very good representation. They don't follow generally what the points are truly doing here. So my recommendation is to maybe ignore that first point because it looks like it might be some sort of outlier. And I would choose one of these other 2 points, maybe the 19,100 and the 2091. Okay, so I'm going to go with those 2. You can choose 2 different points, and you might get similar results. Hopefully for this one, it should be pretty close to the same. So here, really, I'm looking at the ordered pair 19,100 and the ordered pair 2091. I mean, that's what these are as ordered pairs, and I'm asking you to find the equation of the line. Well, I need the slope, and I need the y-intercept. The slope, I just have to do my slope formula, the change in y over change in x. So let's see, y was a 100. Now it's a 91. It's gone down 9, so that's a negative 9. X was a 19. Now it's a 20. It's gone up 1, so that's a positive 1. So my slope is negative 9. From here to find the y-intercept, to do the same thing that I've always done, I start with a fresh y equals mx plus b. And I plug in what I know. I know that the slope is negative 9. And now I just need an x and a y value to plug in. Well, I have an x and a y value. Okay, I've got 2 of them. I'm going to use the second one, the 20 and the 91. Now we just have to plug this in. That's 91 equals negative 9 times 20 is a negative 180. And now I just have to add the 180 to each side. So I find out that b equals a 271. So that's my b value is 271. So my equation, my prediction equation is y equals negative 9x plus 271. And the thing that it asked me to predict, if I look up at my chart, is I want to predict how many hairs are going to be left when I'm 30. I want to know what I have to look forward to. So I'm going to plug the 30 in here. Y equals a negative 9 times 30 plus 271. So negative 9 times 30, that's going to be a negative 270. So plus the 271, so that's going to equal 1. And that doesn't mean 1 hair left on my head because remember, this is in thousands. So I've got 1,000 hairs left, so let's not jump the gun. I've got still more than Homer Simpson, which works out pretty well for me. Okay? For this page, we're just matching. We've got to match the graph with its equation. And I'm going to start by looking at the graphs, and then we'll find the equation from there. In number 18, I've got a y-intercept of 3. So I know there's going to be a plus 3 at the end of this equation. And then I just have to count the slope. It looks like I go down 1 over 2, so that's a slope of negative 1/2. So I'm looking for y equals a negative 1/2 x plus 3. And it looks like that's letter C. So number 18 is letter C. In number 19, again, I start with the y-intercept. The y-intercept looks like it's right here at 2, so it's a plus 2. And then I just have to identify the slope. The slope looks like it goes up 2 over 1. So up 2 over 1 would be a slope of 2, so we're looking for y equals 2x plus 2, which is letter F. So number 19 is F. Number 20, again, I look at the slope, or the y-intercept. The y-intercept is down here at -4. So now I'm going to have a -4 at the end of this equation. And now I just have to identify the slope. It looks like I go up 3 over 1. So that's a slope of positive 3. So I'm looking for y equals 3x minus 4, which is letter A. Number 21, I've got a y-intercept of -4, so I put the -4 down. I've got a slope that goes up 2 over 3. So up 2 over 3 is a slope of 2/3. So it's y equals 2/3 x minus 4. Y equals 2/3 x minus 4 is letter E. Number 22, it's a horizontal line. Remember, horizontal lines are always y equals equations. And in this case, the y value that I'm consistently staying at is -3. So it's y equals -3. And again, that's like a slope of 0. So this one is y equals -3, which is letter B. And now the last one we have, again, I've got a y-intercept of 2, so it's a plus 2. I've got a slope that looks like it goes, let's find a point that it goes through. Looks like it goes up 4 over 3. So up 4 over 3 in the positive direction. So y equals 4/3 x plus 2. So 4/3 x plus 2, that's letter G. So the last one is letter G. And that's it. So identify the y-intercept, identify the slope, and match it up with the equation. For this one, we're actually just doing some graphing. This is in y equals mx plus b format. So again, my slope here is 2. My y-intercept is a -4. And you always start with the y-intercept. So I'm going to start by plotting the y-intercept at -4. So there's -4. And now the slope is 2, which remember is like 2 over 1, rise over run. So I go up 2 over 1 and put a point, up 2 over 1, up 2 over 1. And I could do this all day long. The more points I use, the easier it will be for me to make my line straight. And that's it. That's all there is to this one. Okay, it's just a linear equation. For number 25, I kind of start off the same way. I'm going to graph the line y equals 2x minus 3. That's the linear portion of this inequality. So again, I start at the y-intercept of -3. And it's got a slope of 2, so I go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. I could do that all day long. And now because this is an inequality, I have to decide whether I'm going to use an open dot or a closed dot. If we notice right here, I've got a greater than symbol. I use not an open dot or a closed dot, a dotted line or a solid line. It's the same concept. If I have an equal to condition, one of these guys, I would use a solid line when I draw my graph. But if I have no equal to conditions, I have to use a dotted line when I draw my graph. Since this one doesn't have an equal to condition, it means I'm going to use a dotted line. Which, of course, it looks like a machine drew this because I practically am a machine. But anyway, if we look at this guy, now we have to shade one side or the other. Since I want to be greater than this line, I think I'm going to shade this side. So I'm going to choose the point 0, 0. I'm going to plug it in. So 0 is greater than 2 times 0 minus 3. And see if this is true. 0 is greater than, it looks like, -3. And 0 is greater than -3. So that means this point that I circled works, which means every point on this side of the equation works. So I shade that whole thing. Okay? Hope this was helpful, and good luck on your test tomorrow.